Morning, everybody. This is session 20, and this will be going through electrical systems for the shelter. Every shelter, even if you make your own shelter, you ought to have in your operator's manual, you ought to have an electrical system diagram so you know exactly where things are so you can fix things. So in case something happens to you, someone else can fix your electrical in the shelter. I usually put at least 2D drawings on there, sometimes 3D drawings, so it can be clear how the electrical current is distributed, where the breaker boxes are. So this should be in every shelter, and it should meet the NEC code and or the marine code. The deep cycle batteries, like lead acid, work fine. They do produce hydrogen gas, so that's an issue in a closed environment. But if you go to the AGM batteries, the deep cycle AGM batteries, they don't produce hydrogen gas, and you can get a lot of cycles out of that. Not that you need that many in the shelter, but you want to set up an energy system so you can have at least 6 months to a year. Then what makes this great is that the valve regulated AGM batteries have a system there where these valves actually make the water that normally escapes goes back into the battery. So that's why they are considered closed. And if you break a battery in half, which we've done, we've dropped it from the entranceway to the bottom and broken an AGM battery in half, it's dried, nothing spills out. So they're very dependable. They have a long life. We've had them now for over 10 years, and they're still sound. The other problem that I see in a lot of electrical systems is a miscommunication, either in the manual or to the customer. A 12-volt battery is not fully charged at 12 volt. A 12-volt battery, if it has 12 volts, is only 25% charged. Full charge is up here, almost at 13 volt, and the chargers are usually about 14 volt. So this should always be in the operator's manual or up on the wall of the shelter, so you know how to read that battery voltage. So you know that 12 volts means you got 25%. So that's the problem. 12.7, 12.8, you got a 100% fully charged battery. Most generators usually start at about 12 maybe 12.5, somewhere in here, 12.5, 12.8, and they kick the generator on. And the depth of charge relates directly to the number of life cycles that battery can actually go through. This is an AGM battery. So if you discharge the battery to 50%, right here, you've used 50% of it, you can do that about 1,000 times. If you discharge it only 20%, right here, you can do it almost 2,500 times. So that's important. When I size systems, I usually don't have a depth of charge more than 20-25%. And as the battery sits there, most of the shelters are going to be below 70. So you're in this line here. This is 68 degrees, so if the battery's sitting there, it's not being used, the inverter's off if you have one, and that battery is going to take over 12 months, it's going to go down to 60%. But if it's 104 degrees, like for an above ground shelter, or they're stored, then it's going to go down below almost 50% in 4 months. So the best way to make a battery last long is to keep it charged. Don't do deep cycle discharges. Always keep it charged, and we've gotten over 10 years on the AGM batteries. And the new batteries, by the way, the lithium batteries, they have a computer chip in it that's subject to EMP, so I don't use those. And here's two different types of systems for distribution panels. I used to use these marine panels, which are fine. it just seems like they're not cheap. First of all, they're pretty expensive, but it's just that the wiring on the back is so disorganized. They just hang there. There's nothing neat about it, I just stopped using them. If you go to a QO panel, don't use anything but a QO panel. QO panel, we have a statement from the manufacturer that it'll work for DC, and we've actually tested that. So these are nice and neat. These are normal panels that you buy at a local store. It's just got to be the QO version, not the crap that the home builders buy. QO panel with QO breakers, and this seems to work pretty well. I like this a whole lot better. And if you have a building inspector who's going to be inspecting it, he knows what to look for. This is not going to throw him. If you have a shelter like this, the building inspector comes in and he doesn't know anything about 12 volt or 24 volt power. That's not covered under the electrical codes, and that can be good or bad. But I think this is a much better way to do it. Another way of getting power is you can have self-contained underground power plants. Small ones, big ones, however you want to do it. But this is a 12 kilowatt with a 500 gallon tank in the bottom, and this is outside of the shelter. There's good and bad points about it. The good point is it's an isolated atmosphere that's away from the shelter. The bad point is if this is in any type of chemical environment, biological environment, this is now contaminated. So now to work on this, to do anything with this, you got to suit up. There's much to see at the ground. This is big enough where you can get in there and you can work on it. The inlet and outlets are all around here. The other way to do generate power for a shelter is you can have an EMP shielded generator. There is only one engineering spec for an EMP shielded generator, and that is the mil spec 188-125, and it's pretty extensive. The theory that I hear from on some of the internet chats, where you put aluminum foil, or it doesn't work. Aluminum foil is not a shield. It isn't even close. So this has got waveguide manifolds in here, so it lets the air go through but keeps the EM frequencies out. And there'll be more about that in some other chapters. This is another way to do it. If you want to not have an isolated environment, not EMP shielded, you can force air into the shelter, all your breathing air, and the requirement for this generator, put the shelter under positive pressure. And this is an RV generator with the exhaust goes right out and then up out of the shelter. It's an okay way to do it. For more commercial shelters where you've got 50, 80, maybe 200 people, we usually set up a generation pod with fuel tanks under the floor or attached. Then be a 10,000 gallon underground tank, double wall tank, adjacent to this structure. And it isn't so bad as all the air that comes through here goes up and goes out, but all the air that comes in has to go through these NBC air filtration units, and that gets pretty extensive and expensive. But that's the only way that you can do it if you want to truly isolate this from severe environments. And you can put your washer dryer here where there's direct power. So this is one system that we've made a number of that worked very well. A little noisy, but it works very well. These are some of the NBC air filtration units right here. We've got blowers on the back blowing out, putting this bank of NBC air filters in suction and negative pressure, and putting the shelter in positive pressure. And here's a battery bank, which is just a backup. So you can see here the exhaust is going out here, the hot air is going out here. And how you do this, because this is hot, that takes a little bit of skill and engineering. The other thing that the other way that we do some of the generator power is to build an EMP shield enclosure. Again, the Mill 8 188 125, and it works pretty well. You have to be careful of this exhaust up here, but because this is pretty hot. But any air that comes in, any air that goes out, any point of entry, no matter where it is, it has to be EMP shielded. Another way of doing EMP shielded generators is you can have a power cell, a shielded power cell, above ground, and you can have 500 to 1,000 gallons here, generator here, EMP shield here for the air coming in, EMP shield here for the wave going out. Power goes out to the building through here so you can access it, and there's an EMP shielded gasket around here with a cover. This is an okay way to do it. It's not a hidden way to do it. It meets all the codes. It's exposed to the weather. You know, if it's going to be out in the cold, you have to add some fuel additives. And you notice here there is a filter. So every month you go out and you filter all the diesel fuel in here through this filter, and every year you add some additives. And if you do that, we've kept diesel in the ground for 10 years now. That's still good, as long as you can circulate it, filter it, and add the additives, the emulsifiers. We've gotten 10 years. I don't know what the limit is, but we're at 10 years now. And on the bigger shelters, you can have a separate isolated room. And this is an okay way to do it. It takes a little more room. This is a 16 by 40 S16, and these go sometimes 80 feet long. This is a 40-foot one, and you've got the generator here, the exhaust here, batteries here, and here's your bag in, bag out air filtration system. So it is isolated. It's not so much for fumes or air. It's actually more for noise. But you have a little kind of normal area here, and a normal area here, and food storage up in the walls. This is a long-term shelter.